Hey everyone, welcome back to my channel. Today I'm going to go over a practice chemistry unit test I did. So basically I have a unit test coming up for chemistry, and this one didn't count for marks, but the one next week will. So I decided I will go over this one and see what I got right and see what I got wrong. I've actually already marked it myself, so I'll explain my thought process for the questions, and for the ones that I got wrong, I labeled them. I'll try to figure out why I got them wrong, and hopefully you guys can follow along with me. So, just for context, this test was on nomenclature, so basic IOPAC, balancing equations, and reactions. So, let's get started. So, I know that there are a lot of questions here. This was actually a test, I know. So in order to not bore you, I'll just do the first 5 of each here. So that way it's not as time consuming, all right? So I recommend you have a periodic table with you when you do this. Make sure you have a metal activity series with you as well, and make sure you know your polyatomic ions. I do have one over here on the side, but I'm not really going to use it because once you do a lot of questions that involve using the periodic table, you just end up memorizing the charges. So I won't be using it today, but feel free to grab one yourself. So here we go. So the first question, carbon disulfide, all right? So when I see this, I see that we have a carbon and a sulfur. So both of them are nonmetals. So that means it's a molecular compound or covalent compound, right? So we all know, so we have to write a formula for this. Well, there's only carbon here. There's no di, tri, penta, hexa, deca. It's just one. It's just one. So the symbol for carbon is just C. So it's C. That's why you put C there, right? And then for sulfur, well, you have to add the ide. I'm not going to go over rules on how to write names for chemical equations. Plenty of videos on YouTube for that, but basically in a molecular compound or ionic compound, for the second term you have to add ide at the end, so IDE. So instead of sulfur, it's called sulfide, okay? So this one, it says disulfide, and di means there are two, right? So it's S because that's a symbol of sulfur, and you put a 2 because there's a di, okay? Now the next one, 1B. So this one I actually got wrong. After I checked it, it wasn't because I didn't get it wrong because I just didn't know what was going on. It just I wasn't looking at the question carefully. So that's something I need to keep in mind for when I do it next week on the real test. So basically, this says nitrogen triiodide, right? But I thought this was saying trioxide. I know it doesn't even look like oxide, but I just saw O in there, and this I, it's hard to tell. It's hard to see it if you don't know, if you're not paying attention. So I wrote N because there's only one nitrogen, and the symbol of nitrogen is N. And then I wrote O because the symbol of oxygen is O. But it was iodine, and the symbol of iodine is I, so it should have been I, but I put O. And then you put a 3 here regardless because there's a tri here, and tri is the prefix for 3. So the correct answer was Ni3, but I got that one wrong because I just didn't read the question carefully, so I'll make sure I do that properly next time. So alright, on to the next question, 1C. So dichlorine monoxide. So what do I see here? Well, I see that we have a chlorine and an oxygen. So that means we have a molecular compound, all right? And you can see here that there's a di in front of the chlorine. So that means we're going to have 2 chlorines, right? So that's why, so Cl is the symbol for chlorine, and you put a 2 there because you have a di, right? And then mono means just 1. So you may be asking, why is there no mono for carbon and nitrogen? Because there's only 1. Well, you see, if you only put mono if the element, there's only one of the elements, and if it's for the second term. So there's one carbon and one nitrogen, but it's the first term, so you don't put mono. But if it's the second term, you have to put mono, right? So in this case, it's monoxide. So there's only one oxygen, and the symbol of oxygen is O, so it's just one O. So Cl2O. All right? So I got that one correct. So D, stannic chloride. So this question involves knowledge of the classical system. And it's not really used too much, but for my grade, you just have to know it. But after, like next year, I won't have to ever use the classical system. But just because it's on my test, I'll go over it. Usually you would use the stock system for it, but you have to use the classical system for this type of question. So stannic chloride, all right? So basically, I'll get the periodic table for this one in case you, because stannic, it's not anywhere in the periodic table. So stannic is basically another name for tin, all right? And as you can see, there's a 4 plus and a 2 plus charge, all right? So the Greek term for it, it's called stannum, all right? Stannum. But if you're using the higher charge, so in this case it would be the 4 plus, you have to change it to ic at the end. So that's why it's called stannic. And if you're using the 2 plus charge, the lower one, you have to add the like us at the end. So it's stan us, right? So here it says stannic, all right? So that means we're using the 4 plus charge because 4 is the higher charge out of both of them. So stannic chloride, all right? So this is, I forgot to mention, this is an ionic compound, and we know that if it's ionic, there's no need to put mono chloride because it's ionic, all right? So the charge of chlorine is 1, so it's a 1 minus actually. So if we have a 4 plus for stannic and a 1 minus for chlorine, how do we balance that? Well, we need 4 chlorines because 4 chlorines means 4 negatives, and if stannic's 4 plus and 4 minus, they cancel each other out. They make it equal. So that's why you have to have Cl4. All right? So the last one for this side of the chart. So ferric carbonate, all right? So again, we have to use the classical system. By the way, the classical system only applies to iron, tin, lead, and copper, all right? Every other metal where you have 2 options or 3 options for a charge, just use the stock system. No need to use the classical. And really, I'm pretty sure you can just use the stock system for iron, tin, lead, and copper anyway. Just in my grade, you have to use the classical system. So here we have ferric. So I was talking about what does ic and us mean. So I believe it's ferrum for iron. It's the Greek word for it. But as you can see, there's an ic here, right? Ferric. So that means it's going to be the charge that's higher, all right? So iron, there's a 3 plus and a 2 plus. It said ferric, so that means we're using the 3 plus because it's higher than 2 plus. And ferric carbonate, all right? So carbonate is a polyatomic ion. Carbonate right here is CO3 2 minus, all right? So this is also an ionic compound because iron's a metal and carbonate is not. It's a non-metal, so maybe that wasn't right, but it's just what is it? It's an ionic compound, okay? So basically, here we have to. Here, I'm gonna get a piece of paper for this because it's easier to show it. Give it 1 second. Just getting some paper here. Okay, guys. Sorry, this has been used already, but you know, I'm broke. I don't want to waste paper. So here we have ferric carbonate. I'll write it here. I think writing it here is good, right? Yeah, ferric. So this is going to be a 3 plus and that's a 2 minus. So basically, when you write formulas, the symbol for ferric, also known as iron, is Fe, and the symbol for carbonate is CO3. All right. So when you have this type of question, you just cross over the charges, all right? So like this 2 goes over here. So this represents 2 iron, and this 3 goes over here. And with polyatomic ions, if you have to add a charge, you put it in brackets because of this subscript. You don't want to mix the amount of the elements you have with the subscript. You put a 3 here, all right? So you have 2 irons and 3 carbonates. And that makes sense because if iron has a 3+ charge, if you have 2 of them, that equals 6+, right? And if you have 3 carbonates and there's a 2-, well, 3 times -2 is -6. So 6+ and -6, they cancel each other out, all right? So that's why it's FeCO33, all right? So there we go. We're done that. So now we can go on to the other side of the chart, all right? So, sorry there's a Rubik's Cube there. I just gotta cover out some personal information. But here we go anyways. So now instead of writing the formulas, we're writing the names for the chemical equations, all right? So this is carbon and chlorine, all right? So this is a molecular compound because they're both non-metals. And as you can see, there's only 1 carbon, right? So that's why we put carbon. And there are 4 chlorines, right? So the Greek prefix for 4 is tetra. So it's tetrachloride. And remember, you have to add the "ide" at the end for the second term, okay? And that was right. So now this HCl, so hydrogen and chlorine. So this is actually an acid because there's hydronium in it. If you don't know what an acid is, just think of it as having hydrogen in it. If hydrogen's in something, it's an acid. So basically, there are many ways to categorize acids. It's kind of difficult to explain right on the spot. Basically, I'll try and go through this quickly. Sorry if you guys don't get it because I don't explain it well. But basically, if there's hydrogen in it, it's an acid. I said that already, right? So regardless of if it's an element or a polyatomic ion, you have to change the ending to "ic", all right? So that's why it's "ic", chloric, instead of chlorine or chloride. You have to change it to "ic", okay? But so in that case, it's a chlorine, right? So it's hydrochloric, and you have to add the acid at the end, right? But chlorine is a element. It's just an element. It's not a polyatomic ion or anything like that. If it is a polyatomic ion, so let's say it's phosphate, all right? Then it would just be phosphoric acid, okay? It's just phosphoric acid. It's not hydrophosphoric acid because it's a polyatomic ion now, right? But let's say it was just regular phosphorus, right? Then it would be hydrophosphoric acid, okay? So if it's a polyatomic ion, there's no need for the hydro at the beginning, and you just say the name, adding the "ic" at the end. But if it's just a regular element, not a polyatomic ion, you have to add hydro at the beginning. So here, chlorine, it's just a regular element. It's not polyatomic. So that's why you're adding hydro at the beginning. So hydrochloric acid, all right? So that's done. I was correct. So now for the next question. Chromium oxide, right? So chromium is one of those elements where you have 2 options for the charges. It can be 3+ or 2+, right? And for this one, you don't have to use the classical system. You can just use the stock system. And it probably doesn't even make sense to use the classical system for a question like this. So basically, oxygen, there's only 1 oxygen in the formula. So oxygen has a 2-. So if chromium has options of 3+ and 2+, which one do you use to make the compound equal? Obviously use the 2+. So you put in the Roman numerals like 2. So there, that's correct, right? The next one, manganese and sulfur, okay? So as you can see, there's 1 manganese and 2 sulfurs, okay? So this is an ionic compound, okay? Because manganese is the metal and sulfur is a non-metal, and manganese has 2 options. It can either be a 4+ or a 2+, okay? And sulfur is a 2 minus, okay? So as you can see, there are 2 sulfurs. So that means if sulfur has a 2 minus and there are 2 of them, it's gonna have a 4 minus, okay? And the options for manganese are 4 plus and 2 plus. So how do you make it equal? Which charge do you choose for manganese? Obviously the 4 plus, because 4 plus and 4 minus cancel each other out. So you write manganese, and then in the brackets you put 4, you represent it in Roman numerals, sulfide, all right? So now the last one that we're doing, it's ionic compound because it's nickel and phosphorus. So nickel's one of those elements where you can have multiple charges. So I believe for nickel it's a 2 plus or a 3 plus. And for phosphorus, the charge is a 3 minus. So you pick 3 plus to make it equal. So it's nickel 3 phosphide, all right? So that's it. For the first section, you can see how long it is. It's a lot. And I got 39 out of 40 on it. I missed out on this second one, as I explained earlier. All right? So now we're on to acids and bases, okay? So basically, the question's asking, write neutralization reactions for the following. Put the chemical formula for the acid in a triangle, put the chemical formula for the base in a circle, and put the chemical formula for the salt in a square. Now, I don't really know what it meant when it said put the chemical formula for the salt in a square. So I just put it around the answer and it turned out to be right. So go look that up yourself if you don't know what it means either. But otherwise, just keep watching. So, sorry guys, I get a stuffed up nose when I talk for long periods of time. So anyways, lithium hydroxide and chloric acid, okay? So lithium has a +1 and hydroxide has a minus. So it's lithium hydroxide and it's even already. Then we have chloric acid, right? So as you can see, there's no hydro in front of it. So that must mean it has to be polyatomic. So chloric. So obviously it has to be chlorate then, right? Because chlorate changes to chloric. And chlorates, by the way, ClO3 minus charge, just 1 minus. And hydrogen has a plus, so it's already equal. So HClO3, all right? And in my previous video, I was talking about double displacement, right? So the process is the same, but it's not called a double displacement reaction. This is called a neutralization reaction because you're adding a base and an acid, right? If you add a base and an acid, it's a neutralization reaction. So basically, you do it the double displacement way, but you don't call it that. So lithium will combine with chlorate, so LiClO3, and hydrogen will combine with hydroxide, and that's just H2O, it's water. You don't write HOH, it doesn't make sense. You just write H2O. Okay? And as you can see, this is a really bad circle, but I put the base in a circle, the acid in a triangle. This is a really bad shape too, and this is salt, I guess. Don't know why, but it's just salt, and it was right, okay? So I won't go over, I'm not gonna go over the second one, no need to, but here's the back side. So now we're on to combustion reactions, all right? So for propane, draw a bond diagram of this molecule, okay? So basically, what is propane, right? Well, propane is a hydrocarbon, right? And you just have to know this, but propane has 3 carbons in it, all right? In fact, I'll just say them all right now. So methane is the first. Methane has 1 carbon. So I'll just say them in the order. So the first one I say is going to have 1 carbon. The second one's I say it's going to have 2 carbons, and then there are 10 of them. So the last thing I say is going to have 10 carbons, all right? So it goes methane, ethane, propane, butane, hexane, heptane. Wait, let me start over. It goes, what was it again? Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. All right? So for propane, we know that, you just have to know this. Propane has 3 carbons in it, right? And in order to figure out how many hydrogens there are, you simply just multiply by 2 the amount of carbons and add 2, because as you can see in this diagram, each carbon has 2 hydrogens on it. So you multiply it by 2 and there are 2 hydrogens at the end, so you just add them up. So the chemical formula, or is it equation, whatever it is, for propane, it's C3H8, all right? So now, write a balanced incomplete combustion reaction, okay? So, first of all, we write the incomplete reaction, okay? So, like I said, C3H8 is propane, right? And now you just have to know this as well. An incomplete reaction has its own formula, okay? So for incomplete, it goes plus O2, and it reacts to H2O plus CO plus C plus thermal energy, all right? Just for context, a complete combustion, it's O2, so it's the hydrocarbon, whatever it is, plus O2 reacts to water, CO2, and thermal energy, okay? But this is incomplete. So that part was correct, right? But here I have to balance the equation too, and according to my teacher's answer, it was wrong, but I think I'm correct. So let me pull up his answer real quick. You'll see some lights. I'm going to type. Okay, so let me just check his answer real quick. Go here. Oh wow, he hasn't seen my question yet. I answered the question. Okay, that's okay. It's the weekend anyway, so. Let me see. Okay, here we go. So apparently there are 2 answers for this question in order to balance it, but my answer of 4, 11, 16, 6, and 6 wasn't one of them. So I'll just read out one of them to you. One of his answers is 2, 5, 8, 2, 4. Okay? And his other answer was 1, 3, 4, 2, and 1. Okay? So I checked both of those answers and they were both right. But my answer of 4, 11, 16, 6, and 6 also looks right. And let's actually do it, okay? So 4 times 3 carbons, that's 12 carbons, okay? And on this side of the arrow, there's 6 carbons plus 6 carbons, and that equals 12. So it's equal to the amount of carbons on that side, okay? And 4 times 8 is 32. So that means there are 32 hydrogens on this side of the arrow. On this side, 16 times H2 is 32. 32 hydrogens on this side of the arrow. And there are no other hydrogens on this side of the arrow. And now 11 right here times oxygen, 2 of them. 22 oxygens on this side of the arrow, okay? 16 over here times this oxygen is 16. Plus 6 times this oxygen is 6. 16 plus 6 is 22. And there are no other oxygens. So it's technically balanced, but I don't know, like, apparently it's wrong because it's not one of the answers, but I think it's right. But I marked it as wrong because I didn't do what he did. And I tried to look for ways to simplify things. But the thing is even if I simplified my numbers, they still wouldn't equal his answer, my teacher's answer, so I didn't. All right, so I'm gonna skip over these because this is kind of related to what we're gonna do next anyway. But here we go. Which one am I doing here? So I'll just do the first two. I know we're not going to cover all the reactions here in balancing equations, but I did a reactions video already, so you can go check that out if you want. It's already on my channel. So here, basically, I'll do one on top, okay? So it's sulfur plus oxygen equals sulfur dioxide, all right? So, okay, if you want me to read it the proper way, it's oxsulfide. No, oxsulfur plus dioxide, okay? And that reacts to sulfur dioxide, okay? So my first thought here was there are 8 sulfurs here, and there's only 1 sulfur here. So in order to balance it, I have to add an 8 here to make this S8, all right? But now that there are 8 here, that means there's 16 oxygen, because 8 times O2 is 16. So how do I make that equal? Well, I have to add an 8 to the other oxygen, and it's equal. All right? And as you can see here, these reactants are elements are combining to form a new product, so it's a synthesis reaction. S stands for synthesis, okay? So now, the next one, we have aluminum bromide plus chlorine reacts to aluminum chloride plus bromine, okay? So this is a single displacement reaction. And why? Because you have 2 anions competing for a cation, right? And we know that when you have 2 anions competing for a cation, the cation is just going to go to the other anion. The reaction's always going to happen. So aluminum was with bromine before, but now it's with chlorine, right? So that's how we know it's a single displacement reaction. So I put SD for single displacement, okay? And then for balancing, right? So we have aluminum here, it's equal already. But we have 3 bromine and 2 bromine here. So when you have an odd number of an element, you should try and get it so that it's an even number, all right? So there are 3 bromine, right? So how do we get it to an even number? We can add 2, so then it becomes bromine 6. There's 6 bromine, all right? So if there's 6 bromine on this side, how do we get this bromine to equal 6 too? Well, there are 2 of them here, so we add a 3. So then it's bromine 6 as well because of the 3. All right? But now that there's a 2 here, that also means there are 2 aluminum, right? So we have to add a 2 here to make this equal for aluminum. But now that there's a 2 here, that means there's 6 chlorine. So we have to add a 3 here to this chlorine 2 to make it 6. Therefore, it's equal, all right? Okay, guys, we're almost done. We're almost done. Pretty sure no one's even going to watch this all the way, but okay. So here, you know what? This is actually what I did on the other page. It's just I have to actually complete the reaction myself, but I already explained how it works. So that's going to conclude today's video, guys. Sorry that my speech got like slurred at the end. Just I have trouble breathing when I talk for long periods of time because my nose gets stiffed up. I'll be uploading more hopefully, and hopefully the videos can get better. But until next time, I'll see ya.